All right, I'm going to go through the answer key for your homework assignment from Wednesday. As we talked about in figuring out if the length make a triangle or not, is that we're going to take two of the numbers and subtract them. So 15 minus 12 is 3, and then we're going to add them. And then the question is, does the third length fall between those two? So going back to GeoGebra, when we were moving that green point from left to right, trying to figure out that total range of values at work, at the far left end, when it became a line segment, that's when the two numbers get subtracted. That's the smaller number that doesn't work. And my slide goes in the other direction, make it to the longest side. It's the longest side that actually puts another line segment when you add the two numbers together. So this first one here, definitely 9 falls between 3 and 27, so this would be a yes. But we talked about the fact that it doesn't really matter which two numbers that I select, and the answer is no, it doesn't matter. So if I subtract 10 and 9, I get 1. If I add them, I get 19. 20 does not fall between those two, so that would be a no. And problem 3, and if I would choose, let's say 28 and 70, so if I subtract them, I would get 58. And if I subtract or add them, I'll get 98. And 47 doesn't fit between them. Actually, this would not be 58. Let's subtract them again. Let's try that again. Let's subtract them 42. 42 plus 28 is 70, and 47 does fall between them, so this is actually a yes. Problem number 7, I'll choose the first two numbers. So if I subtract them, I get a 5, and if I add them, I get 15. And 15 actually is the first number on the bigger numbers that doesn't work, so it's a no. Problem number 9, choose two numbers, so I'll choose these two here. So if I subtract them, I get 9.8. And if I add them, I get a 14.2, and 14.3 falls outside that range, so number 9 is also a no. 23 and 16, so if I subtract them, I get a 7, and if I add them, I get 43. And the number actually is that first number on the short side that doesn't work, so this is a no. For the next group, if I subtract them, I get 2. And if I add them, I get 15. And 13.5 does fall between those two numbers, so that's a yes. In problem 6, if I subtract them, I get 13. And if I add them, I get 69. And 13 is actually that first number on that small side that doesn't work. And anything less than 13 also doesn't work. And if I select these two numbers here, if I subtract them, I get 31. And if I add them, I get 49. And 41 definitely is between those two. So that's a yes. And then the last one, 6 and 9, if I subtract them, I get 3. If I add them, I get 15. And 16 is going to fall out to the right. And so therefore, it's not between 3 and 15, so it's a no. So the whole idea of this idea of a range is to provide you not only an idea of what single number you're making a comparison here works, but actually the range of all the numbers that will work. So for number 1, for example, not only does 9 work, but any number between 3 and 27 will work. And problem number 4, for example, not only does 13.5 work, but any number between 2 and 15 works. As long as it's bigger than 2, smaller than 15, it will work. Same thing with number 8. Any number between 31 and 49 will work. So 41 works, but anything, again, bigger than 31 and smaller than 49. In problem 11, mistake on my part, there was supposed to be a number on that last problem. And problem 11, so if you look at the problem 1, I had absolutely no idea how to do this problem. That's the reason why. So the first problem, the angles are marked to be the same, so we have an isosceles triangle, so x is 6. In the second problem, we have two equal sides, and that means the line of symmetry goes through angle x, which means the other angle on the other side is 54 if I fold the triangle in half. So 180, take away 54, take away 54. What I'm left with is 72 degrees. That's the value of x. Problem 3, or the third problem, here's my line of symmetry because I have an isosceles triangle. And so this angle here is 75. So that line of reflection, fold the triangle in half. In the next problem, they still use the 75, but put the x in a different place. So if I fold the triangle in half, using this line of symmetry, because of the equal sides here and here, that's going to be 150 degrees. So 180, take away the 275, which is 150, and what's left is 30 degrees. That's the third angle. The next triangle, we actually have an equilateral triangle, so that means all three sides are equal and all three angles are equal. So that's 60 degrees. In the next problem, we have an isosceles triangle, so the line of reflection goes through the 84. So 180 degrees, take away the 84, leaves me with 96 degrees. And that 96 degrees is actually divided among the two angles that remain because they're congruent. Keep in mind, talked about this last week again, that these two angles are called the base angles. They're the ones that are equal. And the angle that generally is not going to be the same is called the vertex angle. So these base angles, I take them and divide 96 by 2, each base angle is 48 degrees. The next problem, the line of symmetry goes actually through the 40. So that means I have 180 degrees, take away the 40 degree angle that we have, we're left with 140 degrees. If I divide that by 2, that means each base angle is 70 degrees. And then the final problem, because we have two equal angles, that means these two sides are equal to each other. So 62 is equal to 2x plus 28. If I subtract 28 from both sides, I will get 34 equals 2x, and divide by 2, so x is 17. Make sure that's right. All right, on the next page, here we're trying to identify the type of triangle that we have based on the information we're given. So we have three equal angles, which also means we have three equal sides. So the triangle is equilateral. So number of equal sides and number of equal angles for a triangle is the same number. And the triangle is also acute. We define that on the biggest angle. In this case, the biggest angle is 60. The next triangle, we have two equal angles, which means there's two equal sides. And basically, we must split the triangle this way, the 72's on top of each other. The triangle again is isosceles, and the biggest angle is acute. So this is an isosceles acute triangle. Next triangle, we have two 31-degree angles, so we kind of divide it this way to get that line of symmetry. So it is an isosceles triangle again. We have two equal sides. We know that because we have two equal angles. And the biggest angle is 118, so the triangle is obtuse. So this is an isosceles obtuse triangle. And the last one, all three angles are different, which makes the triangle scalene. And the biggest angle is an acute angle. So this is a scalene acute. We actually name triangles by both names at the same time. So the first triangle is equilateral acute. Next one is isosceles acute. Third one is isosceles obtuse, and the last one is scalene acute. But usually when we talk about them in class, we usually say one name or the other, but the actual name is both things. All right, problem 13, we are trying to find that missing angle measurement. So these two angles are a linear pair. Also, angles are supplementary, they have 180. So that makes this angle here is going to be 70, 180 minus the 50 minus the 60. We're going to see what's left. So the question mark is 70. Angle next to the 140 is 40 because those two angles have to add up to 180 degrees. So 180, take away the 40, take away the 45. So basically taking away 85 degrees. So you're going to be left with 95. That's going to be the question mark. The third angle, this is problem. This angle is 70. 70 because the two angles have to add 180. So the question mark is going to be 30 because 180. Take away 80 and 70 is 150. So what's left is 30. The next one, we have 180 degrees. We're taking away the 80 and the 25, which is 105. So we're left with 75 degrees left. And because these two angles are a linear pair, that angle has to add to, those two angles have to add up to 180 degrees, so that's going to be 105 degrees. The next one, 180, take away the 35 and the 95, so basically 130 degrees. That leaves me with 50 degrees here. And that makes this angle here going to be 130 because, again, these two angles should have to 180 since it's a linear pair of angles. So the question mark is 130. And then the last one, we were given the 70 and a 50, so we're basically taking away 120. So what's left is 60. And so, again, a linear pair, so the question mark here is going to be 120. Now, what they're asking for here is, can you look at the angles, the X, the Y, and the Z, and can you come up with a relationship between those three angles? So going back to the previous problem, it references, so they're asking, I'm going to go ahead and mark out the angles here. So if I take away the angle that is next to the exterior angle, and if I eliminate the angle again that's next to the exterior angle, what they're asking is there a relationship between the three angles that remain? So is there a relationship between the 70, the 50, the 120, the 95, 45, and 140, the 80, 30, 110, and so on. So looking at this problem 14, the three angles that have not been crossed out in problem 13, can you come up with a relationship between those three angles? I'm not going to give the angle or answer away, but we'll move on to the next problem. So in problem number 15, I have 12 and 16, so that means my range is going to be 4. I subtract the two numbers, and my range, and it's going to be the top of the range is going to be 28 when I add the two numbers. So that means the third side, all those numbers have to be between 4 and 28. So 15 and 25 and 9.8. Those numbers are between 4 and 28. 28 doesn't work because it's that number that is where the first example on the big end that doesn't work. The 4 doesn't work because that's that first example on the short end that doesn't work, going smaller than that. The 32 falls outside the range, so that's why those three do not work. Problem 16. You have an angle bisector. So what an angle bisector does, it actually divides the angle in half. So that means the 5x plus 13 and the 8x minus 19 are going to be the same value. So if I subtract 5x from both sides, I'm going to have 13 is equal to 3x. Add 19 to both sides. So I'm going to have 32 equals 3x. And then if I divide both sides by 3, x is going to be 32 thirds. So about 11. It's actually 10 and 2/3 or 10.6 repeating as a decimal number. But again, I prefer that we keep these things as fractions and not repeating decimal numbers. Last two problems, which ones are correct? It will be these two here are correct. The reason why this one's not correct is because that symbol is used for comparing two shapes. And these are both numbers. So, and this one here, that's an equal sign, which means they both have to be about numbers. This isn't a number, it's a distance. So that does work. But this one here is a shape. So we have an issue between the equal sign and the things we're comparing. And the last thing is, it has to do accurately a perpendicular line named BC. And again, because it is perpendicular, there should be a right angle mark there. It's supposed to go through point M, so hopefully yours did. So hopefully, if you have any questions, let me know when we meet next. We'll talk about it. Please upload the assignment since it's due.